All right, we have seen that benzene is stable. I show you the energy diagram. We have calculated just a little stabilization energy of benzene. Now, benzene, we know benzene is stable. But now let's put it into practice. Okay, let's do some reaction. How do you know if benzene is actually stable? I'll give you some example here. We have seen this reaction together in chapter 8. You can put bromine onto an alkene, and you get two bromines on it. Okay, a benzene do this reaction. Benzene refuses to do this reaction. It doesn't do it. Another example, we can do hydrogenation on an alkene, right? And it produces an energy, and you guys know this. On benzene, nah, not doing it. So it refuses to do this reaction. But you can force benzene to do this reaction. You have to increase a large amount of temperature from 2 atm to 100 atm. Right? The temperature from room temperature to 150, you force the reaction to happen. Okay, so benzene refuses to do the reaction. If you want to do a reaction on benzene, you have to make it happen. Okay. Now, I would like to look at the energy output real quick. Start right here. One alkene do hydrogenation. The energy is coming out of this reaction is 120 kilojoule per mole. Okay. So if I have three of this, think with me. All right. If I have three of alkene do this reaction, what would this energy be? Should be 360, right? 120. So three of them should be 360. Now come down here, benzene, 3 double bond. It should be 360, right? But it produces only 208 kilojoule per mole. The difference right here, the difference between 360 to 208, that is the stabilization energy, 152 kilojoule per mole. For a small molecule, 6 carbon like this number is massive. Okay. All right, I'll show you the energy diagram. So one double bond, do hydrogenation, 120 kilojoule per mole coming out. Two double bond, but this one is conjugated diene, have some stabilization energy. All right, so instead of it's supposed to be 120, it's supposed to be 240 kilojoule per mole. The energy comes out only 232. Okay, so 8 kilojoule per mole stabilization energy. Benzene, we expect 360 because there are 3 double bonds, only 208 observed. You know, that's a stabilization energy, and it's really, really big. So my bottom line is benzene is really stable. Back in the day, when they just started discover benzene, right? There aren't a lot of aromatic compounds yet. So we're gonna go back in time to find which compounds exhibit stability just like benzene. Let's take a look on the next video.